Hello, welcome to another lesson. In the last lesson, we learned Wireshark basics with capturing and filtering. In this lesson, we are going to be analyzing HTTP and DNS traffic in detail. We will examine web requests, decode DNS queries, identify malicious patterns, and understand redirects. This is practical traffic analysis for real security work. Before we dive in, make sure you have your Kali Linux running or any of your Linux operating system. And if you're using Windows, Wireshark can work on Windows too. So you are welcome. Now let's dive in. The first thing we want to do is to start our Wireshark, and then we're going to run sudo Wireshark and then enter the password. Now our Wireshark interface is up. So I'm going to click on any because I just want to capture from any interface. Another thing we are going to do is in the terminal, you are going to open another terminal. So you can come here in the terminal here. We want to use CURL. So we can use CURL HTTP. Then we add google.com. So after we had run that, we can come back here and you can see that our Wireshark has captured the packets. So you can come back to the red square here and then stop Wireshark from running or from capturing. Now you can see that we are having DNS, TCP, HTTP, TCP, ICMP, ARP, and ARP. So the next thing we want to do is to filter out the HTTP traffic. So we can come here and type HTTP. Now we filtered that. So we are having just two left. And once you've done that, you should see HTTP get and then HTTP 301 moved permanently. And after we've done that, the next thing we want to do is to analyze our HTTP request packets. So what you need to do is to click on this get, and in the middle panel here, you can try to expand this hypertext transfer protocol. So you expand this, you click on this arrow here. So you can try to bring this up a bit. And now you can see the request method, which is get. And here you can see the full request URI showing the full path. And it is usually just with / for home page. Also, I want you to know that the HTTP version is usually 1.1. So the next thing I want to do is to expand this get request. And once I've clicked on that tiny arrow, you can see that we are having another information here. Here you can see the request URI. Can you see it with the /? You can see the request version. You can see the request method to be get. And also you are seeing the host here, which is google.com, which is the destination. You are seeing the user agent header here. And this is showing our CURL followed by the version number. And here you are seeing the accept header showing what content types the client accepts. I want you to know that the user agent is particularly interesting because it reveals the tool making the request. And here that is why you are seeing CURL. So attackers often leave user agents from tools like CURL, Python request, or SQL map, and that makes it easy for us to detect. So that is all for the get request. So you can come here and click on this, which is the one that is carrying 301 moved permanently. And once you've done that, you can see that we are having another details here. And here you can see the status code, which is 301. That is after you have expanded this hypertext transfer protocol. So what this 301 means is that it is a redirect telling the client the resource has permanently moved to a new location. So you can close this. Here you can see the location, and after location you can see the content type showing you the text /HTML. And after that you can see the content length here, and content length shows the size of the redirect page. And you can see 219 here. Also, you can open it to see the content there. Can you see content length 219? And you can close this back. Also, before I forget, what the location header does is that it shows where the redirect is pointing to. That means that you might be loading an HTTP version of a website and then it's pointing to the HTTPS version. So when something like that is happening, that means it is forcing HTTPS for security. Our status code, as I mentioned earlier, is 301 and it's a permanent redirect. And websites use this to migrate from HTTP to HTTPS. That means that the browser would automatically follows the location header and makes a new request to the HTTPS URL. And that is why we are seeing 301 there. And here are the common HTTP status code that you might see. You can see 200. So when you see 200, 200 means the request succeeded and the server returned the content. When you see 301, that means moved permanently, which implies that the resource permanently moved, like from HTTP to HTTPS. Another one is 302, and that stands for found, and this means a temporary redirect. The next one is 304, which means not modified. And what this means is that the cached version is still valid. And we have 400, which stands for bad request. And this means the client sent an invalid request. We have 401, which is for unauthorized. And this means authentication is required. We have 403, which stands for forbidden. And this means access is denied even with authentication. We have 404, which stands for not found. And this means the resource doesn't exist. We have 500, and this stands for internal server error, and this means that server crashed or had an error. And you can be seeing 501 and different versions of 500. Just know that they have to do with internal server error. So understanding these status codes would help you identify normal traffic versus errors and attacks. The next thing we want to do is to capture HTTPS traffic to see the difference. So to do that, I will clean up this. I can cancel this. So I will come back here, then I can start a new capture, and I would click continue without saving here. And after that, I can come here, then I would change this to HTTPS and run it. And now I can come back to my Wireshark, and you can see that I'm having some new set of packets or traffic being captured. I can try to drag this down. And this time around, we are not filtering for HTTP. What we want to do is that we want to come to our protocol column here, and we are going to look for TLS v1.3. You can see TLS v1.2, but 1.3 is like an updated version. So here we are seeing TLS v1.3. You can see that here. So the next thing we want to do is to click on the TLS packet. You can click on this, and you can come here and try to expand this. And now we can come to our transport layer security. So you can toggle this, and you can see TLS v1.3 record layer, and you can toggle this again. And if you look at this, you can see the content type, the version, and the length. So you can come here again and toggle on the handshake protocol. And this is going to show you all the details as regards the handshake protocol. You can see the session ID length. You can see the session ID itself. You can see the random that was created during the handshake. You can see the cipher suites because this is not HTTP, this is HTTPS, and it is more secure. And every other details that has to do with the handshake protocol. Also, you can come back here and probably click on the one that has to do with the server. So this is where the server is saying hello. So you can click on this and then come here again. And this time around, you are seeing that we are having the record layer in two different places. And then we're having like a TLS segment below it. So this is just showing us some information similar to the first one we checked. So the next thing we want to do is to probably click on any of the packets. And then when you click on that, if you check here, you can see that the data is encrypted. Can you see? So this is just like jargons. But if you look at that of HTTP that we tried earlier, you will see that you can see something that you can read here. Another thing you can do is to right click on this, then come to follow, and you can come to TCP stream. And here you can see that we are seeing some scrambled data that we don't understand. And if you check this for HTTP, you are going to see the request and the response here, and it's going to be readable. If you want to know more about that, you can check our previous lesson. I had explained that there. And if you come to the TLS layer security here, you are going to see the TLS record layer, which is the handshake protocol. You can see the content type, you can see the version. This time around, you can see version 1.2. And here, if you come to the TLS record layer, this is for the change cipher. You can see the version to be 1.2, even though we are seeing 1.3 here. And here you can see the TLS segment. So we can close this. Another thing I want to mention is that we cannot see the GET request, the headers, and the response in this case compared to that of HTTP because everything is encrypted. Now let's try to analyze post requests with HTTP. So let's try to capture an HTTP post request to see forum data. So the next thing we want to do is to start a new capture, and you're going to come here, then continue without saving, and click on OK here, then come back to your terminal and then try to run this command. So here you can see CURL, you can see -x, then you can see the request, which is post request. You can see the -d, and you can see that we're adding the username, which is admin, and we're adding the password, which is test123. This is the URL to the web application platform, and this is the post request. So what this command will do is that it is going to send a post request with username and password. So we can run this, and now you can see an output in JSON format. So what we can do is to come back to our Wireshark, and you can see that it is being captured already. The next thing we want to do is to find the one with post request here. So you can come here and filter that out first. You can say HTTP, and here you can just look for the one with the post request. You can see that this time around we are not seeing 301, we are seeing 200, and I've explained what the status code 200 means earlier. So you can click on this, which is that of the post. Then come here, you can see that this time around we are seeing a post request instead of a get request. You can see that here. You can see the request method to be post. You can see the request URI to be /post instead of ordinary / that we saw earlier for HTTP. And here you can see the host, you can see the user agents and all other details here. Also, if you check this side, you can see that we are seeing something readable. You can see HTTP 1.1. You can see the host. You can see the user agent. You can see the details here compared to that of HTTPS. HTTPS will only show you some scrambled data here. You are not going to see anything there because it is encrypted. Another thing you can do for this is to right click on this, then come to follow, then to TCP stream. And here you can see the request. You can see everything here, right? And if you look at this, you can see the response here. And this is readable compared to that of HTTPS. You can see that we captured the username and the password. And what this is telling us is that HTTP is dangerous. Credentials and sensitive data can be completely visible to anyone capturing traffic. And this is why login pages must use HTTPS. Next thing we want to do is to try extract HTTP object. And to do that, we need to close this. So you can come here, remove this, and then type HTTP again. And after you've done that, what you want to do is to go to file menu. But before then, let's stop this. So then come to file menu, then you come to export objects, and you come to HTTP objects here, then you click on it. You can see that a window has opened showing all the HTTP objects. And HTTP objects can be the HTML pages, the images, the JavaScript files, the CSS file. It's just anything transmitted over HTTP. And here you can see the packet, the host name, the content type, the size of the object, and then the file name. The next you want to do is to select any of the objects you want to extract and then save it to disk. So we can select this, then we can click save. So the next thing is to pick the directory where we want it to be saved. I can come here and come to desktop, projects, then Wireshark, and try to save it here. And now I've saved it. And if I want to save all, I can just come here and click on save all. You can see the previous one I saved earlier here, and I can just hit enter and everything will be saved. So if I want to check what I've saved, I can go to that directory and check it. And this is useful for extracting downloaded malware, examining malicious JavaScript, capturing evidence, or analyzing what files were transmitted during an incident. So if you come back here, you can look for the directory. So I am going to come to desktop, then come to projects, then come to Wireshark. And now I can see the file here. So you can try to open the file. And here you can see the username and the password in the file. Also, you can open the second one, and here you can see the response that we generated when we ran the command with the post request. So those are the objects that were generated when we were capturing. The next thing we want to do is to filter for DNS traffic, and before we do that, we need to capture DNS traffic first. So what we need to do is to first come to our Wireshark. We can delete this, hit enter, then come here to start a new one, continue without saving, click OK, then we come back here to our terminal, and then we can run ns lookup google.com. And what we are doing here is that we are trying to query DNS to resolve google.com to an IP address. So the next thing we want to do is to come back to our Wireshark, and we can stop the traffic because you can see that it has captured our DNS traffic. So stop this. Click on the packet having the standard query. So after that, you can come here and expand the domain name system here. And you can see the transaction ID. You can see flags, you can see question 1, you can see answers, you can see authority. So here you can click on the queries. You can see that the record type is A. If you want to understand record type better, you can look for one of my videos where I'd explain that. I've explained that during the course of this cybersecurity course. Also, transaction ID is a unique identifier that is matching our queries to responses. The flags here is showing that this is a standard query. And here you can see all the details as touching the flag. And here you can see that we're having one question. And if you come down to the query section, you can see that we are having the google.com here. The record type is type A. And if you come, you can see the name field showing google.com. You can see the type again showing A. And you can see the class showing in, and that means internet. So the record type A here means we are asking for IPv4 address. And what this is doing is that it is telling that with the client, we are asking for something. And what we're asking for is, what is the IPv4 address for google.com? And if you come here, you can see the IPv4 address here. And if you come here, you can see the IPv6 address here. And the moment we clicked on this, you can see that we are seeing an answer here. Also, if you click on this, you can see that we have an answer here. So this is for IPv4 and this is for IPv6. So if you want to filter DNS by query type, and what you want to see is just the A record that is querying for IPv4 address, what you can do is to come here and then type your DNS.qry, which means query, then .type equals 1, and you hit enter. And this is going to show you just the queries asking for IPv4 address, and that is why you can see that here. You can see the IPv4 address. And don't forget, IPv4 is using the A record, so IPv6 will be using the quadruple A record, that is AAA and AA in 4 places. So if you want that of IPv6, here you can just type 28 and you hit enter, and this is going to be showing you just the ones for IPv6 address. You can see that the address here has changed to IPv6. If you want to check for that of the mail server record, you can use 15 and you hit enter, but just because we didn't capture anything like that, we are not seeing that. And that's how you can filter DNS traffic or packets by query type in Wireshark. Another thing you can do is that you can filter by domain name. So if you want to filter by domain name, you can just come here and you still type your dns.qry.name instead of type, and you're going to add equals. You can type google.com and you close it and you run it, and it's going to bring out all the DNS queries with google.com as the domain name. Another thing I would like to show you is the DNS statistics. So you can come here, clear that, hit enter, and then come to statistics here, then come to protocol hierarchy, and you can look for the domain name system in the hierarchy or in the tree. And this shows the total DNS packet, the percentage of traffic, and the byte count. You can see all the details here. The last thing we want to do is to run a practical example that shows how to analyze web session. And for that, we can come back to our terminal here. What we can do is to run curl and then we type our L because we want to follow redirect. So we are going to type HTTP, then google.com. But before we run it, we need to close this first and then come back to our Wireshark and start a new capture. Then we can come back to our terminal and then try to run this. So what the head flag there is doing, as I mentioned earlier, is that it is going to help us follow the redirects. And now you can see the response. So we are not just seeing the one for google.com alone, we are seeing for every redirect that is happening on that page. So the next thing we want to do is to come inside our Wireshark, and you can see that we are having a lot of traffic here already. So what we can do is to filter for HTTP. And now that we have filtered for HTTP, you can see that we are seeing the initial GET request to HTTP for google.com. And after that, we can see the 301 moved permanently response. And if you click on this, you are going to see the location header here. And what it's doing is that it is redirecting us to HTTPS version of google.com. And if you come to the last one here and double click, you are going to see all the information that were captured. You can see the headers here. You can see the cookies. You can see the XSS protection header. You can see the X-frame header. And normally we shouldn't be seeing all of this because they should be encrypted. So that's all for this lesson. But before we go, I have a challenge question for you. And the question is, why does Google redirect from HTTP to HTTPS with the status code 301? I come again. Why does Google redirect from HTTP to HTTPS with status code 301? I'll be waiting in the comments to get your answers. So thank you so much for staying through and watching this video till the end. If you have any questions, please do not hesitate to drop them in the comments as well. And also do not forget to like, share, and comment. Thank you so much once again, and see you in the next lesson.